Good afternoon, everyone. My name is Ruchi Kushwaha, and I'm from IIT Bombay. Will be starting the event shortly. Before starting the event, I would like to just mention few things. First is that we are recording this event at our end. Also, due to paucity of time, we have an open Q&A session of 10 minutes only. So during the course of event, if any participants have any question, I request you to put it in the chat box and we'll be taking up the question from the chat box itself. The post-event material will be uploaded on the Grid Integration Lab website and LinkedIn page. Also, as and when the speakers come up, I request you to kindly turn on your mic and camera. So first, let me walk you through to the agenda for this event. The event will start with the inaugural address by Professor Shireesh Kedare, Director, IIT Bombay. Then we have Shri Ashok Kumar Rajput, Member Power System, Ministry of Power, CEA, Government of India for the keynote address. Then we have a presentation on status update of field demonstration of V2H/V2H and on the study implementation of vehicle to everything V2X in India by Professor Zakir from IIT Bombay, followed by a very interesting panel discussion on V2G technology and its adoption. Due to certain urgent exigencies, Professor Matia couldn't join us with us today, but we are happy to have our other panelists. We have Mr. Bjoern Christensen from Next Dimension USA, Mr. Ramkrishna Singh, Head of EV Charging Operation Tata Power, Dr. Sandeep Garg, Deputy Executive Director Technical SIEM, as our panelist, and it will be moderated by Professor Zakir itself. So let us start. Then we'll have a Q&A session where we'll be putting up the questions from the chat box, and then the event will end with the vote of thanks. So first and foremost, I would like to invite Professor Shireesh Kedare, Director IIT Bombay, for his inaugural address.
Thank you. Thank you, Ruchi, and thank you, Professor Zakir. You can hear me, right?
Yes, sir.
Yes. So, very good afternoon to all of you, and it's very interesting to be with you all, and this very interesting subject of the vehicles connected to grid. So this is very interesting because maybe I'll give some background of one study that I had done. Actually, our student has done is that we evaluated what does EV do to the grid and how the EV increase or decrease load on the PV. That was one study that we had started, and we found that if the EVs are connected to grid, and most of them, maybe 60%, are connected to grid in the night because throughout the day they go around and a lot of things. So in the night at the residential place, they are connected to grid. In that case, it's basically the thermal power that goes up. Because in the night, solar PV is not available. So even if there is lot of renewable in the grid, the energy consumed by the EV is basically backed up by thermal power by burning coal or of course gas. So this is a serious problem in the sense that now we have a battery, and so this problem can be solved by batteries. So what it means is, yes, during the daytime we have renewable energy, we have wind energy in the early morning and late evening, and they can be extra also. They are generating something. If we increase the capacity, they will generate a lot of energy. But then for night, and if the EVs are being charged in night, you are burning fossil fuels because there is no storage on the grid. Had there been a storage, then they would have stored and then supply. So this is an interesting problem. And again, this is a novel solution that which is a topic of this today's event, is that yes, why not use grid instead of increasing the thermal load? Can they be used to actually pick up the power during day and supply during night. Right. So the storage batteries, because one of the problem with storage batteries is the size. At one place, so many batteries to be managed, and then grid power to be absorbed, and then best it is done in a decentralized manner. So you have batteries. So in fact, you charge batteries during day. So yeah, so the logistics has to be worked out that during day, how do you charge the batteries? You pick up the thing, of course, early morning, late evening, you will drive the cars maybe, but during peak hours of the noon, where the solar energy peaks, the vehicles can be connected to grid. They can absorb all the energy, and maybe in the night they can deliver partially. And so of course battery management, the logistic management has to be done. So that is one of the interesting study, and I think we had done some pilots in IIT Bombay, and Professor Zakir will elaborate more on it. So the problem of transport, problem of electrification of transport, problem of renewable energy on the grid, storage, the carbon footprint, many of them get addressed. So this is a very interesting solution. Uh, I think these new ideas need a lot of support, and new ideas also need to be studied, experimented, especially in the challenge of sustainability. The major part is innovations, because I feel that the industry today may not drive the transition. It may not be like converting to hydrogen may not be economic, and so maybe it's not profitable. So many times it is done by policy. So alternatively, instead of the conventional industry, can we have ideas? Can we have fresh minds looking into the issues, addressing the problems in a fresh manner? That is another way of moving towards sustainability. So I think today's effort is very interesting, and I congratulate all the team to think of this and organize it. So we have a car. I see that car, grid connected vehicle car in IIT. So yeah, Professor Zakir will talk about it. And welcome to this event. And thank you.
Thank you, Professor Shireesh, for your useful comments and your inaugural address. We are very grateful for your time that you took from your busy schedule and joined us in inaugurating this event. So now moving to the next agenda item, which Ruchi took us through, I would request now Mr. A.K. Rajput, who is Member Power Systems at CEA, Central Electricity Authority, who has been involved in electric vehicle charging infrastructure and related aspects, apart from his other expertise, core expertise that he has for a while. And then with IIT Bombay, he has been involved in this EV related aspects for last 4+ years. So therefore, without spending much time, I would request Mr. Rajput to go ahead with this address. Over to you, Mr. Rajput.
Namaskar, sir, and namaskar, everybody. I am A.K. Rajput, Member Power System, CEA, Central Electricity Authority. Actually, let me tell one thing, that role of every power professionals who is dealing with the electricity, either generation, transmission, or distribution, it is to meet the consumer requirement all the time. Another factor is that the power, whatsoever is being served to him or is being supplied to him, is at the reasonable rate. This is commercial aspect. Another thing is that whatsoever the pollution is being caused in the whole supply chain, right from the generating end and up to the user end. And in this case, the user end is the electric vehicle battery. Everywhere the efficiency counts, electric batteries for the purpose of driving the vehicles, they are evolving day by day. And maybe the experts can tell and what the trend has been, whether the efficiency is increasing and at what pace the efficiency is increasing of different technologies through the improved process, improved minerals and the improved material. So first thing which we have to do and all the automobile manufacturers have to do, put in the R&D effort, that the efficiency of these batteries should be improved. What is being done through these EVs is that the pollution because of the tailpipes in the crowded locations of say like any city, any lanes and any street, any road, that is getting reduced. Suppose the vehicle is there, it is in idle condition and it is in the start mode. So naturally some pollution will keep on taking place. Such a pollution will not be there when we are using the electric vehicle. That is the first criteria that why there is a move towards the electric vehicle. In every case, a balance has to be maintained. The balance is basically the fluctuating load cycle and the utilization of the RE resources. Since RE resources, no fuel is consumed and this is the gift of nature, we are trying to make use of this gift of nature in different forms. Electricity either for transportation in a big train, large train and the goods train, metros, also for the purpose of lighting, industrial use and the comforts of the house, comforts of the home. So this basically anybody can tell that these are the normal usage of the electricity. Of course, these are the normal usage of the electricity from which source is sourced. Either it is hydro, it is thermal and various sources of the renewable energy. Always the effort have been that we burn less coal to get more of electricity, and whatsoever the hydro resources are there, and now in the modern era, whatsoever the renewable resources are there, they are utilized in an optimum manner. They balance the grid also, they support the grid, and since solar energy is a daytime phenomena, it has been thought that this particular energy be utilized or the equivalent energy of the solar be utilized for charging of the electric vehicles. Vehicles are the normal phase. Let me start the technological upgradation and give the example of the railways, which I usually give. Railways were using the coal-based engines, causing lot of problem. They were less efficient and a source of pollution all over the journey. Then came the more efficient one. Since the efficiency is an innovation, and then came the use of diesel engines and now the electric engines in the transportation system. It has been established that generating the electricity and supplying that to the grid and using it in this heavy transportation is an efficient method as compared to the burning of diesel. Similar type of the things we are trying to modulate or give a model to the electric vehicle. The penetration of electric vehicle is limited. Of course, it is increasing, but there are certain barriers. One is the cost, another is the parking space, particularly in the cities and also in the small towns. And another is that what to do with the existing vehicle, which is running on either petrol or diesel. So these are certain things. Now with the help of the studies and innovation, certain models are coming, can be utilized whatsoever the energy has been stored in the batteries say at a particular instance, and that particular instance, I suppose, and we have an assumption in this one, that this particular electricity has been utilized when there was excess in the grid of the renewable energy. So excess of the renewable energy, that is the clean energy, has been stored in the chemical form. And this chemical form we will utilize when we have to be wise enough, and we have to teach the people and the users that really when there is a crisis, the grid is under real stress, that time these many vehicles or a fleet of vehicles owned by say Ola and others, if that is available and at different points, that can support the grid. That's the real advantage of V2X. In case of the V2 home or V2 building, the similar principle applies. Their contribution to the grid may be little, but in case, say, my particular distribution transformer or the utility has devised a program, utility has developed a business model through participation and the consumer research, that you are a vehicle owner, and if you are a vehicle owner, can you support us? Can you provide the support when demanded and when there is going to be real crisis? So that is one model. Another is that electricity is not there at all in your home. Maybe some local breakdown or the power is in shortage and you are experiencing the power cuts. That time, what to do? Though it is a costly affair or the costly resource available with you, but you can use it. It would be economical. It would be economical if this electricity has been used from the renewable sources of energy and when the rates of electricity have been lower. So, lot many infrastructure has to be developed. Further advancement could come when there are the dynamic prices and the real pricing is visible to the consumers, and he has the facility and additional infrastructure. By saying V2X and V2 anything is quite easy, but implementation is challenging. Reason being that there could be only limited facilities or the limited infrastructure where this V2X could be used. Certainly the studies need to be conducted, the interfaces need to be developed. We do not know what breakthrough can come. Maybe the small modular reactors in the form of the nuclear power, they may evolve, and from those nuclear reactors we can get, or there is a possibility that in this era of competition we can get a cheaper energy. I'm not sure it will happen or not, but this is one of the scenarios. Another scenario is that you are having the rooftop solar and you utilize that particular rooftop solar, save the electricity and do your household activity with that type of the electricity. In case of, say, I am advocating of the vehicles which are to run on electricity in the form of, say, the electric tractors also, as there is in some of the countries, the electric tractors are also there, and tractor is a multiple usage technology, transport, irrigation, carrying the load. This particular tractor equipped with the electrical battery and charged during the time when lot of renewable was there, and that was going waste. There was no load in the grid, and that was going almost the waste, or the wind or solar were being asked to curtail. So these programs can be devised with the help of the load management, having a quiet interface and the communication media with the local grid at the state grid or the national grid. Another is the depot charger. Depot charger could use this type of the facility that when excess RE is there, they can be motivated or they can be allowed to charge. This usually happens during the night time when the peak demand is not there. These vehicles, say as an example, say electric run tractor, they could be used for V2X very easily. Usually it happens or it is seen that in the villages, the power supply is in the limited sense. And the studies, students suffer that their studies becomes cumbersome or uneasy to them. So the owner of the tractor will have a choice, either he can use that facility in his home, or maybe some community places or community spaces or the panchayat ghars are there. Those places could be lighted up. The children studying there, they can make use of such type of the facilities. So it will be a real time, the real growth or the Indian model for the rural masses, where the V2X facilities could be used. Another is V2X could be used in the distributed energy supporting form. The distributed energy supports the whole grid in the time of the peak, and a lot of heavy current which has to flow all over from the generating station right up to the load centers, that would be reduced. The grid could be used for more important load like manufacturing of the chips at the data center and other major loads, say steel industry or the continuous run industries. And the local loads or the town loads or the village loads, they can be these vehicles, whatsoever has been charged, they could be a supporting component in the wide areas or the widespread distributed energy resources technologies. Naturally, the time will come that we will not be having the right of way for constructing the high voltage lines as we are progressing. There is a certain limit to each and everything. So similar limit will be imposed on the use of our soil, use of our say lands, because we have to protect the forest also. And day by day, the laying or establishing of the high voltage transmission lines and associated substation, it is becoming challenging. So the distributed energy resources will have its own path. And in that series, another thing will come, the production of the hydrogen. And that hydrogen, if is available at the economical cost, will be a cause and will be a factor in the industrial revolutions. Because hydrogen and green ammonia, they can be used in many forms of the chemicals. So whatsoever the gases will be saved, they could be used for other purposes, maybe for power generation also in the emergencies when the peak is there. In the electricity, basically what is most challenging is not the breakdown, not the voltage conditions, but the peak which is being experienced and our equipments are not able to support. So there we can find and make use of such distributed facilities. But before that, the strong communication network is to be established. The interface from V to anybody, V to anything, say V2X, V2 buildings or V2 home, those are to be developed. And when it comes, what would be the measurement or the measuring arrangements for its own use? V2 home is simple, but when it is V2 grid, the tariff issues and the transactions, because the transaction will be on a small quantities, lesser quantities. And for that, whether the consumer will be attracted or not, suitable models have to be developed. Maybe in some specific localities, those are say well-to-do localities and have the resources of this kind and they are ready to serve. There these models can be applied in the beginning. Later on, as the model develops and as the things develop, the other models can be developed. It will depend on case-to-case basis that what suits to the public, what suits to the individual, and what are the facilities available to him and what is the tariff for charging of the from the public charger or from the charging from the point which is at its home. So these are few words. So I will stop here and thank you everyone. Thank you.
Thank you, sir, for inspiring words. It was truly enlightening. Moving forward, now I would like to invite Professor Zakir from IIT Bombay to kindly present on status update of field demonstration of V2G, V2H, and on the study implementation of vehicle to everything V2X in India.
Thank you, Ruchi. Share. I hope you are able to see the presentation in presentation mode.
Yes, sir.
Okay, so a very good afternoon to all the participants. So this presentation is going to cover two aspects. One is some of the aspects of the study that we have been doing around this V2X implementation, and then we'll move to the overall status of V2G field pilots, one of the field pilots that we have been conducting, and show some of the analysis, some of the findings that we have been able to arrive at, and some of the applications or use cases that Mr. Rajput was mentioning, or the potential multiple potential use cases he mentioned it. So some of those use cases have been demonstrated through this pilot, which we'll talk little more later in this presentation. So background, I think we all know, is climatic action that needs to be taken up on priority basis, which is being taken up across the world at different levels, both at the regional, national, and the global level. And coming to the Indian perspective, we know that some of these news you can see highlighting the issues around the rising temperatures. Many of those rising temperatures being attributed to climatic changes and other aspects. So therefore, looking at the broader motivation behind this electrification of the transportation sector is carbon neutrality targets that have been set again at the global and national as well as regional level. And you can see transportation is contributing to around 21% of the emissions. So therefore, to achieve net zero goals, it is very, very important that all the energy vectors, not only power sector, but also other energy vectors, here transportation being one of the important, those energy carriers need to be decarbonized to achieve this carbon neutrality. So looking at the Indian targets, we already have different major targets around renewables, including 500 gigawatt by 2030 and beyond. We already have a reasonable penetration of renewables, which is predominantly solar and wind. And we are having ambitious targets of integrating several hundreds of gigawatts of these solar and wind as we move forward in this journey of integration of renewables. And we have this net zero target by 2070. So therefore, to achieve this net zero target at the country level, all the energy vectors need to be emissions from all the energy vectors need to be addressed. And now coming to the transportation sector, countermeasures or the policy interventions that have been taken, we have at the central level several schemes that have been implemented. FAME is one of the major ones, which is still in place. Then we have at state level EV policies by almost all states, union territories. We have PLIs around this electrification of the transportation sector, several schemes, multiple tax rebates and other incentives to encourage EV adoption or electrification of the transportation in the country. Now, in that direction, we already have been witnessing adoption of electric vehicles on Indian roads with around 41.24 lakh vehicles, predominantly two-wheeler, three-wheeler vehicles already on electric vehicles already on the road, and more numbers are getting added, as you can see here in this plot, a rapid increase in the electrification of the electric vehicles. Though we are at relatively at the early stage of electrification of the transportation sector, but the targets and the pace at which it is happening is one of the the rapid paces that we are adding this new technology into the system in India. Now we have this electrification of vehicles, which is primarily unidirectional, where we charge electric vehicles from the supply and then we use it for driving. So if we looked at the broader definition of this vehicle grid integration is the broader concept which involves all these electrification of the electric vehicles, EV charging, integration with the grid, and V2X is very specific to bidirectional charging, where this transportation and power sector is actually nexus is happening through this V2X. So that's what is the focus of this study that has been doing, and also the pilots that are being done. There is just some of the applications of these V2X. We have services to grid operator, this discom, behind the meter optimization, backup power supply, different stakeholders you call discommers or any other grid operator, EV user, EV aggregator, and other market operators, different stakeholders can potentially benefit through this V2X application. Now we have done this study, which this was almost for 2 years. This study was carried out, and the reports have been published in Mr. Bjoern, who will be speaking in the panel discussion, was part of this study. Mr. A.K. Rajput from CA was contributed to this study. So there are several techno-economic analysis we have done purely in the Indian context, and then the recommendations have been derived based on that. So some of the aspects, while this is the long study and reported in these reports, all those who are interested are free to visit these links that are provided here through the QR code and can access these reports and go through them. So, some of the aspects I have tried to cover here. In the interest of time, it is only limited points that I have covered in this slide. I am mentioning the regulatory challenges in the beginning in V2X adoption, which includes V2G, V2H, and others, V2B and other V2V and other V2X applications. Though logically technical challenge should come first, but I have put the regulatory challenges in the beginning. The reason being, technically, the technology has been demonstrated across the world in different countries that it is capable of doing these different V2X applications. So what is the major enabler now in this V2X adoption is actually regulatory measures that need to be taken to have this adoption of this V2X in India. The entire focus, though we are giving reference to the global, but that the entire focus of this study and this presentation is in the Indian context. So then we have the technical challenges. Of course, there are technical challenges, not that all the technical challenges have been addressed, but then technologically it has been demonstrated that it is capable of doing all these different use cases or applications that we have mentioned it. Then we have the economic challenges to be addressed, where we have the cost factor to some extent, and also just double taxation when you talk of V2G or V2X services for the battery that is underlying in the vehicle. And then we have the organizational challenges that need to be addressed in this adoption of V2X, and societal challenges are equally important that also need to be addressed in or tackled in achieving this objective of V2X adoption in the country. So looking at the hardware requirement, if we see, we have different hardware requirements apart from the other requirements. V2G chargers, we have as of today, of course, there is slight change in this, but so it is primarily shadow mode charger that is this Japanese charger protocol that is actually capable of bidirectional. We have now CCS bidirectional coming up, but it is not yet fully out in the market. But it's primarily this Shadamo that has been so far doing this V2X bidirectional flow between the vehicle and the grid or the load. And the other issue is that we have, if you look at the number of electric vehicles that are compatible with V2G services in India, as of now, we do not have any electric vehicle model that is compatible for V2G services. Though globally there are, but in India we do not have any such electric vehicle in the market that is compatible with V2G. So therefore, that is another hardware challenge that we have in India. And then grid and metering related aspects that are there, requirements for this V2G service. This is only, again, a snapshot of several studies that we have done in terms of what different applications can be provided by this through this V2X. This is reactive power support for the distribution grid. This study has been done on one of the discoms feeder in India, where we try to see how electric vehicle charging infrastructure can, with bidirectional capabilities, can actually provide reactive power support to the grid. In addition to technical support, that is reactive power support, we looked at the economic analysis also. So you can see here reduction in reactive power drawn and annual savings by this particular distribution feeder for different power factors. You can see is shown here. Of course, this is no more draft now. It is already out now, final. And then we also, in addition to the charges or saving on the charges for reactive power withdrawal with the from the transmission system, we also found the savings in terms of by reducing the losses by providing this reactive power support to the distribution system through this charging infrastructure. So there are potential savings that can be made in terms of the loss reduction, and in terms of the reactive power requirement drawn from the transmission system by the discom. These are the figures that you can see here in terms of savings due to a reduction in the losses. This is around 5,22,000 was saving only because of the loss reduction, but of course there are other applications and savings that can be made by this is one. It was only one of the applications, and of course there are many other V2X applications for the grid support. We also did, apart from grid distribution discom, we also took up this reactive power support in one of the food industries, and there also we found that there can be a potential savings that the grid operator can have by providing the reactive power support from the charging station itself for the industry load. And these are annual savings for this particular study is around 74 lakhs with the existing prices in place. Based on the entire study, as I said, that is reported in those three reports, we have concluded that this V2X adoption can be looked at from the phase-wise perspective, starting from phase 1, where we have this dumb charging, then phase 2, where we have V1G with smart charging, and then phase 3, we have this V2X, and then phase 4, V2G limited, and then finally phase 5, V2G wide spread or seamless adoption across the grid. So starting from grid connection to the grid support using this grid integration is what should be in our opinion, the roadmap for adoption of the electric vehicle, V2X in India. And as I'm repeating again, a lot of details are given in those reports. So in the interest of time, I have captured only few of the glimpses of those studies that have been done. So having said that, let us move now to the field demonstrations that we are doing at IIT Bombay. IIT Bombay is doing. You can see here, there are two field demonstrations we are involved in. One is we are doing one field demonstration at IIT Bombay campus, and another field demonstration is being done on RE based. It is actually PV based, to be precise, EV charging station with this V2G capabilities for a public charging station in Pune. And for field demonstration 1 at IIT Bombay campus, we have 2 pilots. One is pilot 1, which is around V2G and V2H. And then we have another pilot 2 at IIT Bombay campus. And for field demonstration 2, we have 2 pilots that are part of this public charging station, PV-based public charging station in Pune. What I'm going to take you through today is some of the findings, some of the analysis, some of the measurements that we have done for pilot 1. So pilot 2 to 4 are not covered here. Here we are going to talk about only pilot 1. And for this pilot 1, where we focused mainly at home for V2H and V2G, we have used only one electric car because the idea was it is only one house. So therefore, one house is expected to have generally one car. And accordingly, for this pilot 1, these are the different components that we have. Electric vehicle is the first component. And then we have bidirectional charger for this. And these are the parameters of the charger for this house, vehicle to house and vehicle to grid. And then we have this rooftop solar PV system of 13 kilowatt capacity in this house. And these are different appliances that are there in the house: 2 air conditioners, lamp load, ovens, fans, and other household appliances. And this is a 2-story building, and you can see here this Team Shunya building at IIT Bombay campus. And we have this rooftop PV here, and then this is the electric vehicle with vehicle to home and vehicle to home to grid. Basically, through home, it is also supplying to the grid wherever there is a surplus of power. So what we did is, in this entire study so far, is this is the house charging, at home charging that we are doing, both V2H as well as charging at the house itself. And then another setup we have at the office side, where this particular vehicle, electric vehicle, is being charged at the workplace during the daytime, where potentially you can think of solar PV or whatever generation could be there. So these are the broader objectives of the pilot 1. We looked at electric vehicle integration, peak shaving, increased PV utilization, islanded operation of the house, the emergency case where Mr. Rajput was also highlighting in the beginning, and net zero electricity exchange target. Now, if you see the integration part is here, you can see this vehicle is supplying power to the home. Here you can see negative is basically vehicle is providing power to the home, and then in this case it is charging, and wherever required it is again going into the V2G mode if there is surplus power from the vehicle. So this is the integration part, and then we looked at peak shaving. Of course, here there is no PV involved in this particular case, but you can see this is the load, household load, morning peak, and this is the evening peak. And when there's a morning peak, we are activating this vehicle to home, and it is providing this power to the home, and net power is being now exchanged with the grid because negative is there. So it is basically sending power to the grid because we have surplus power generated by the vehicle during this morning peak, and similar activities happening in the evening peak. You can see this is the power supplied by the vehicle to the home, and then surplus power is going to the grid in addition to the local load that it is supplying. So this is how it is trying to do the peak shaving. And then increased PV utilization. Now we considered here PV also, the rooftop PV that I was mentioning, which we are using to charge and also address these morning and evening peaks and increase the utilization of the solar PV system. Then this emergency case where there is a power failure or there is a load shedding from the grid side. So you can see here we try to demonstrate how if there is the power outage from the grid side, and you can see instantly the vehicle is starting supplying the power, and it is taking over the supply responsibility of supplying the local load in the house in the absence of the grid. And you can see during this entire period, in the evening also, the power is being supplied from this electric vehicle before the grid is coming back here at around 11:30 or so p.m. in the evening. So this is one of the snapshots of course, we have done several case studies. This is one of the snapshots of where we're able to demonstrate that this vehicle is also capable of providing power to the grid under the grid failure as and when required. So this is 1 day measurement. Of course, we have done over the period, but this is 1 day measurement that is being displayed here. What you can see here, this is the load of the house, morning peak, and then we are supplying it from this vehicle to grid or vehicle to home, and the additional power, surplus power, is being supplied to the grid during the morning peak. And what is happening during the day, since the vehicle is not at home and load is minimal at home, so the power generated by the solar PV is going back to the grid. It is using the feed-in tariff basis, it is supplying it back to the grid. While as at the same time, we are having this home charging, workplace charging at the workplace of this electric vehicle. And then when the vehicle is coming in the evening again, and you can see here we have electric vehicle again starting supplying power to the home during peak hours. This right side plot is giving aggregate numbers for this particular day, 9th April 2024. You can see this is the power generated, energy generated by the solar PV. One thing I would like to mention, the solar PV generation capacity of the rooftop PV that we have here is very, very low because of shading that we have due to trees. It's a 13 kilowatt system and generating 15.6 in April, which is enormously, is extremely low. So this is primarily because of shading, and coincidentally because of the construction that was happening around, a lot of dust was covering the panels. So 15.63 is the number of units generated by solar PV, and this is the net power being exchanged with the grid. Basically, we are supplying back to the grid during this day, and then this is a total 21 units consumed by the house load that we have on that particular day, and we have total energy drawn from the grid here, and total energy supplied by the vehicle during the day, and total energy discharged to grid and from home is being shown here. So and then this is the energy used by the vehicle in driving to the office for this particular day. So this is 1 day. So accordingly, we have measured this across the period of this study, these measurements, and then what we did is these are the tariff rates applicable in Mumbai. As you can see, we have for LT residential, and then we'll have LT commercial, and then we have EV charging TOD in Maharashtra applicable to Mumbai. These are the prices that are being considered here, and then we looked at the economic analysis, viability of this. So you can see here, scenario 1 is a flat electricity price that are applicable in Mumbai at the moment, and we do not have any PV here. In case one is where we do not have any PV and there is no solar PV. Case 1 is the base case, and then case 2 is where we have both V2H to G support and also solar PV generation. And then case 3 is where we have both V2G, V2H and G support and solar PV generation. And case 4 is where we do not have solar PV, but it's only V2G, V2H and V2G support. Now, if we look for in case 2, where we do not have any V2G support here or V2H, but it's only PV, we have a reduction in electricity prices on yearly basis of around 15%. In this case, where we have both PV utilization as well as vehicle to grid, vehicle to home, we have annual saving amounting to reduction of around 32% on annual basis. And in this case, it is only V2H and V2G where we have without PV, where we have around 15-16% savings or reduction in the electricity on annual basis. So this was this case scenario 1 was actual scenario. Now what we did is we translated same to other possible scenarios. We assumed that in this scenario 2, what if the same case was for commercial houses, is a commercial building, but the same setting, same PV, same load profile, we tried to see what would have been the savings for that. So here you have with only solar PV around 18% saving, with both V2G, V2H and solar PV around 58%, and only with V2H you have around 40%. With V2H, why it is coming higher? Because the commercial prices are higher, so accordingly you can utilize the V2G more. In scenario 3, what we did is we used a TOD tariff of EVs applicable in Mumbai. And that's where you can see we have, of course, solar PV will remain more or less same with respect to scenario 1. And then we have case 3, that is V2H and V2 and solar PV. You have this, and then with only V2H and V2G, you have around 3% saving. Now compare scenario 1, this case, and scenario 3, this case, they are same except we are taking TOD tariff. So what it shows is in Mumbai at the moment, the residential prices are more profitable to the household user than TOD tariff. So that kind of indicates TOD is not as effective for home charging as you can have simply from by using the residential tariff. But still there is saving even with the current TOD that we have in place. In this particular case, what we did is, okay, so in all these cases, scenario 1 to scenario 3, all the power supply that was being supplied, net exchange that was being injected to the grid, we considered feed-in tariff. For PV, it is already there. For V2G, of course, there is no tariff as of now in place because of the regulation. But for V2G also, whatever power we were able to supply from V2G to grid, we considered feed-in tariff for all these first 3 scenarios. In scenario 4, what we did is we considered net metering for EV charging for household application. So since we considered net metering, you can see in this is with PV, this is with PV and V2H and V2G. This is only with V2G without PV. So you can see here we have here, if we compare it with scenario 1, we have higher savings in V2G because there is a net metering, while as here it was feed-in tariff for V2G. And then we considered scenario 5, which is hypothetical case. What we considered in scenario 5, workplace charging that we showed earlier, is that what if the employer encourages the employees to have electric vehicle adoption and is offering free charging during the workplace from, let us say, local solar power plant. So with free EV charging at workplace, you can see the numbers are coming very, very high in terms of savings, which may not be the case, but we considered this for a hypothetical case just to see how things are different in this particular scenario. And then we took one more case where we considered that if we are doing charging from public charging station instead of home charging in Mumbai, at the moment we considered 18 rupees per unit. Of course, it can be different depending on the prices and the charging station and the CPO that is providing that service. We considered with 18 rupees. So what we found is, look at this plots. Please read it carefully. Here, in the previous case, we were showing y-axis percentage reduction. Now here we are mentioning percentage change in electricity prices. Plus means here increase in electricity prices. Minus means here reduction in electricity prices. So with public charging and then supplying it to home as a V2H, V2G, only under PV case it is having some cost reduction, but with V2G and PV and V2H, actually the costs are increasing. So therefore, what we found is by charging from the public charging station and then using it for V2G and V2H at home is not economically viable in the current scenario. Of course, with the regulation change, whatever may happen down the line, things may change, but at the moment we are doing analysis with existing prices, tariff, and existing regulations. This is again same things. In all the scenarios, we have basically increased prices of electricity and on annual basis if we use public charging station to charge and then discharge it at home for vehicle to home services. This is that hypothetical case where we considered, free office charging to the electric vehicle. So these are some of the findings that we have arrived at so far with the pilot 1, pilot 2, 3, and 4 are ongoing activities. In future, we will be updating on those pilots also, and we're also looking at in addition to the objectives of this pilot 2, 3, and 4. We are also looking at health analysis of the battery, carbon emission reduction through this V2G services, looking at the viable business models that could come up through this V2G services. And finally, which is the main goal, is recommendations for technical and regulatory measures for V2X adoption in India. So with this, I am concluding this presentation. I think I overshot the time assigned to me. Over to you, Ruchi. Thank you.
Thank you, sir, for such an interesting presentation and giving the status update of the field demonstration at IIT Bombay. Now, I would like to invite all of you to join in a panel discussion on V2G technology and its adoption. For the panel discussion, we have Dr. Sandeep Garg, Deputy Executive Technical SIA. Then we have Mr. Bjoern Christensen from Next Dimension USA. Mr. Ramkrishna Singh, Head of EV Charging Operation from Tata Power as our panelist, and this would be moderated by Professor Zakir. Professor Zakir, over to you.
Thank you, Ruchi, and a very warm welcome to all the participants, the panel members, to the panel discussion. I think we have a very interesting topic to talk about today, which is vehicle-to-grid technology adoption in India. I would like to briefly introduce the panelists. First, Dr. Sandeep Garg is currently Deputy Executive Director in SIAM. He has more than 34 years of industrial experience, has contributed significantly in different domains of the energy, electronics sector. And he has a doctor's degree in management from AMU. Welcome to the panel discussion, Dr. Sandeep.
Thank you very much. Thank you very much.
So next panelist is Mr. Ramkrishna Singh from Tata Power. He is heading EV charging business in Tata Power. So he brings a lot of experience from the field in the country with lot of charging portfolio that they have in the country, and he is going to bring us the perspective from the actual field side in the country. Welcome, Mr. Zakir Singh.
Thank you, Dr. Zakir, for nice introduction.
Thank you. And now we have Mr. Bjoern Christensen from Next Dimensions. As I mentioned earlier, he has been involved in this V2X study that I was mentioning, those reports actively over those couple of years, and he has been instrumental in giving a lot of constructive inputs to us in that study, and he has been giving various positive outlook, because he brings a lot of experience in this V2G space with several decades of industry experience in Europe and United States. So what I would do is now welcome Mr. Bjoern for the panel discussion, and what I would do is I would request, I think Mr. Bjoern is having probably a slide to show. So we'll start with Mr. Bjoern's one slider, and then we'll take up the discussion forward. Over to you, Bjoern.
Thank you very much. Can you see my my screen now?
Yes.
Okay. Thank you, Professor Zakir, and thank you for inviting me to this conference. As Professor Zakir mentioned, I have been involved in the project, and I think the project has produced some remarkable results. The idea was to stand on the shoulders of all the other trials that have been done all over the world, and then see how we can map V2X into an Indian context. Now, I just want to show you a couple of slides here that I have done, as a matter of fact, for a conference in Denmark last year. And if you look at the title of my presentation in Denmark, is how to make e-mobility and electrification more affordable, and then a journey through vehicle to everything. And it's complementing what Professor Zakir has done, but I think it's important just these few slides up front. Whatever we're doing in the electrification of everything and e-mobility specifically, it has to be affordable. If it's not affordable, it's not going to happen. And of course, it has to be efficient. Here's a slide that complements also, again, what Professor Zakir said. We are in the middle of a big bang, right? In the old days, in 2010, the electric grid and the automobile industry were two separate industries, both trillion-dollar industries. Here we are, where they slowly are starting to date, and we have some smart charging, we have some public charging, instant charging, but in mostly unidirectional charging. And moving towards 2030, they are getting married, as you can say, the EV industry and the electric grid, and they're producing offspring, which are called vehicle-to-grid integration, where the electric grid and the electric vehicles have to live in harmony. It cannot only be on the electric grids, conditions, and it cannot only be on the electric vehicles conditions. They have to come together. They have different standards, different modes of operation, and so forth. So they have to learn to live together in harmony. And this is what I call VGI. VGI is a term that was coined by California Energy Commission in 2014. And there's no official definition of it, but here's my attempt to define it. There's V1G, which is unidirectional power, and then there's V2X, which is bidirectional power. And in the unidirectional power front, there's instant charging. It's sometimes called dumb charging, public charging. You just want to charge as fast as you can. You don't care about CO2 or sometimes even price. And then, of course, there's smart charging. But over here on the bidirectional side, we can have off-grid. We don't need to be on-grid. It's much easier with off-grid. We can have vehicle to load or vehicle to vehicle, vehicle to home, if you're isolated from the grid, and same for building. So we should not disregard this one here, because that might be very applicable in certain areas of the world, like, for example, in Africa. And then there's an on-grid. The on-grid, we have to be synchronized with the grid, with the frequency, and we have to follow the frequency. We can do vehicle to home and vehicle to building, as was already explained. We can do it behind the meter, so we don't have to let our car help the grid. We can help ourselves first. And then there's a vehicle to grid here shown in red, where we can actually address grid services for the TSO, the transmission system operator, or distribution grid operator. This would be more in the future, and this is where there are a lot of problems will come when millions of electrical vehicles are being integrated in the grid. But one thing is important to notice here, that there will be competition for the use of V2X technology. If the grid operators cannot offer conditions that are, let's say, good for the people and the companies that are actually offering grid services, they will just concentrate on the behind-the-meter services and other services. So the last slide I want to show you is why I think V2X is inevitable. It's all about affordability and efficiency. The EV battery capacity factor is very low. It's only driven typically 2 to 3 hours a day. Whereas if you look at the efficient gas, the solar, the offshore wind, offshore wind, they have much higher capacity factor. And we have to use our resources in the world in an efficient manner. And this is where there's a huge V2X potential. So just this picture alone should be inevitable that we need to use that battery in the electrical vehicles much, much better. And also, all EVs are born bidirectional. If you accelerate, you just transfer energy from the battery to the electric motor. If you brake, you do it the reverse. So it's every EV today is already internally bidirectional. And there's also a business model, which has been shown by Uber and Airbnb. Let's borrow the battery when they're not used for driving and then compensate the EV owner. This will increase the value of the EV and it will lower the cost of owning an EV. So thank you. That's all I wanted to say in the beginning here. And the last comment, V2X is not a silver bullet. It will not solve all problems. But let's focus on what it can do and not what it cannot do. Over to you, Professor Zakir.
Thanks, Bjoern, for your introductory comments and slides that you took us through, giving the background and different types of V2X services that can be provided from the electric vehicles. And the important point that you highlighted, which all of us know, is that the battery of the electric vehicle generally remains unutilized for most of the time in the day. So why not to use it, this unutilized asset, more optimally? So I would start with the broader question of, or before going for the point-wise discussion, I may request Dr. Sandeep if you would like to give some introductory remarks around this this topic.
Yeah, good afternoon, everyone. Am I audible?
Yes, we can hear you.
Okay, fine. Thank you for inviting me, Dr. Zakir, and it's a pleasure to be here in such company. People who are, I know Mr. Singh was here in Delhi with Siam for some time, and we had chatted together on the grid integration part of it on the sidelines. And I think it is a very important topic going forward. But the relevance of this topic, the currently under the FAME scheme and other schemes also, there is a lot of, I would say, challenge in terms of putting up the grid infrastructure for the charging station. I think that's the first point I wanted to make, because the discoms probably are not tuned to provide the charging structures. Unlike, I'm not referring to Tata Power, they are the forefront of this entire activity. But, other than the private discom, the government discom has a lot of challenges. As a case in example, because I'm in Siam, we wanted to install public chargers in and around our community. And believe me or not, even when the services were free, nobody was interested in taking the free chargers, because I think it's a chicken egg story. Who comes first? If the charging stations are not there, people will be hesitant to buy electric cars. And I know going forward, the car business strategy, electrification will play a very, very, very major role. It may be through the electrification of vehicles, and it may be V2X. All this technology, the adaptation is definitely required. And therefore, in my personal opinion, there is a lot of there's a lot of need for keeping the people informed about what is going to happen in future. And I think they must also get rid of this anxiety that that the power is a problem. In fact, as I speak to you just now, the grid is not there, in Noida. So I understand the challenge of it, But nevertheless, I have been deploying solar power, which you showed in your slide, since 2008 at 175 rupees per watt. So for me, I understand the integration of the renewables portion of it with the V2X or any other deployment of technology. The need for people to deploy such type of action on the rooftop is definitely required, and there is a lot of gaps, and this platform is not for identifying those, but I think this is a very good initiative as part of the trial, and going forward, making the standard and regulation for making V2X as a reality in future. I think that's the initial thoughts which comes to my mind, and I request Mr. Singh and others to kindly elaborate on what I said in overcoming those challenges. Please. Over to you.
Thanks, Dr. Sandeep. Yeah. So over to you. Over to you, Ramkrishna. Mr. Ramkrishna, please, your take on this topic.
Yeah, thank you, Professor Zakir. I think it is very interesting and it's very encouraging to see the this large number of audience in your workshop, and also very learned panelist. So thank you for inviting. And V2X is a very interesting marriage. In fact, I would say that vehicle to grid, it is inevitable, and it is a very amazing marriage which is going to happen. So process is already initiated by you. Mr. Bjoern was also talking about very interesting finding. And I'm sure that not only in India, but globally, there is a very huge opportunity in V2X, wherein each EV owner can be a generator of electricity, can be distributor of electricity, and simultaneously he can also drive his or her car. Okay, and while we connect or integrate with the solar, that adds to the overall economic viability, and also our target to achieve the net neutrality by 2070. Although Tata Group has also eyeing for this the net neutrality by 2045, and I'm sure that we are on the right track, being part of this journey. And I wish all of you a very good luck and for carrying out this study. And I'm sure that the pending work which you have shown would be very successful and would be very beneficial to the society at large and also the industry at large. And for Dr. Sandeep, so let me inform you, Dr. Sandeep, that tomorrow I am having a meeting with this UP Power Corporation is having a very good workshop, full day workshop, wherein they are inviting that very senior industry leaders across, including Niti Aayog Vice Chairman. So tomorrow the team would be there for the full day, wherein they are looking forward that how they can enhance the EV adoption in UP and how they can facilitate the EV infrastructure build up. So I'm sure that discoms would come up in a phased manner. They probably need some push, which government is already providing. And I'm sure that regulation would also enable, that smooth transition of electric vehicles, adoption of electric vehicles, and also setting up the charging infrastructures in coming days. So only it's a time, I think, a time factor, which may take another 2 to 3 years. That by that time, discoms be more aware, public can be more aware, and we have the suitable regulations and policies in place to implement V2X, and also, take many other benefits which we are yet to under experimentation stage, or if we are still in thought process. So I'll come back again once you have more queries or the questions or discussion points. Thank you so much.
Thanks, Mr. Ramkrishna, for your thoughtful inputs. See, as I showed in my presentation, there are some of the applications of V2X where we do not, we already have the regulations, for example, for vehicle to home, vehicle to house. And the measurements that we have done show quite encouraging results, where one can have a reasonable savings on the electricity bill if it is used for vehicle to home, even with the current regulations. Of course, the regulations will play a very, very important role for the rest of the V2X application, where we talk of V2G, and other aspects. So I would like to ask your opinion, whoever wants to take it first. What do you think are the major hurdles in the adoption of V2X or V2G services in general and particularly in Indian context?
So anyway, I think in case nobody is coming up, I'll take it up. Maybe then the Mr. Bjoern or Dr. Sandeep can add on to it. So challenges, what I feel is on date, is primarily the technology. That is the first thing, which is still under experimentation stage, and also the barrier of because there are a certain vehicle which have this kind of technology, but they are not into that particular price range wherein the mass adoption can happen. And another part is on regulation side, that like Tata Power is doing home charger installation. So as of now, 95,000 or almost a lakh home installations are in place across India. But most of those home installations are not smart. Number one, they don't have the bidirectional capability, and simultaneously vehicle is also not having the bidirectional capability. Some vehicle which are having the vehicle to load kind of capability, those are also very limited. So unless the the overall cost economics works out by which people will start adopting V2G or V2X kind of technology and vehicle, and simultaneously also on the grid side or the discom side, wherein they allow you to pump and take the energy. While you can take the energy, but while pumping back that energy to the grid, there might be certain constraints on the penetration of electric vehicle or how much energy you can pump. So also the technology also evolving, that through which you can integrate all the vehicles available for participating into the demand response kind of arrangement. Like suppose you think like there are suppose 1 lakh vehicles having 30 kilowatt of battery. So 30 lakh kilowatt load storage capabilities just coming to you at any spot at any point of time. So and handling that kind of load, it geographically is past multiple almost 40, 50 plus utilities. It is a quite challenging in terms of technology, in terms of regulation, in terms of management, in terms of monitoring. So I think the kind of institute you are doing the study or Mr. Bjoern is doing, that would be quite helpful in the future. So these are the few things which are coming immediately on my mind, apart from basic infrastructure related issues. Maybe Dr. Sandeep and Bjoern can come up or add to what I have said.
So can I go ahead, Dr. Brown? Can I go ahead?
Yeah, please, Dr. Sandeep, go ahead. Please.
Okay. So I think very nicely put up, but I will add further, to what you said. The current vehicle regulation does not allow this thing to happen at this point of time. So there will be, anything which you introduce in an automotive regulation has to undergo its, whole field trials and the challenges of regulation, particularly because this is an on-board thing. I understand few of the OEMs are trying it. I don't want to name them, but I got a feedback they are trying it. Because from a pure electric point of view, this makes sense. From a pure electric point of view. The second challenge and the opportunity would be, this would be an opportunity because the OEMs and the vehicle owners may have a connection to the grid directly through the vehicle, which will be a very good thing to do. The second part would be there is, from a consumer perspective, there is already a range anxiety, in terms of the electric vehicles currently in context. So if you start discharging your vehicle or you charge your vehicles, there will be a paranoid situation between the consumer. Just to overcome that situation, which you mentioned is, oh, I am charging back to the grid. What happens if I have to suddenly go out? My battery will be discharged. That type of a situation, I think there's a need for, again, which I mentioned in my opening remarks, there will be a need for education for the consumers to make them learn. I think this concept is a very, very brilliant concept to speak, but for people to learn and to speak their thought process, education will be very much required by the OEMs as well as from the discoms. The third point is the regulatory part. I think renewables do play a very important role in the entire value chain of this V2X type of an integration. Whereas in my personal opinion, I see a very big gap, between the policy framework of putting up renewables on the top of the buildings or in the buildings. While it is happening, there is a gigawatt scale, but I think we have 13 months of sunlight in 12 months, which is a very good boon in terms of providing, back to the grid as far as this thing is concerned. So my take is that there is a lot of education first required. Two, the regulation part on the vehicles is something which needs to be tackled in a long time frame, because that has its own standard making process, and you're going through the iteration and the testing process, which of course you are doing, but it has to be taken to the regulatory level. The third part is that the consumer education, which is lacking in this country, has to be made updated so that people can actually learn what is the scenario in future. That's the simple point. Over to you, Dr.
Thanks, Dr. Sandeep. Right. So, as you said, I would like to put a couple of comments before I request Bjoern to come in. As you mentioned that, there is this earlier, there is chicken and egg problem in charging infrastructure and the vehicles. There is a similar aspect here also, where we are talking of the regulations. If there are not adequate regulations that allow these different V2X applications, so there won't be viable business cases for them, and therefore, as a result, the industry will not be will not get encouraged to do this, get into this kind of business side. So therefore, these studies that are being done by different stakeholders, and the pilots that are being done, for example, in our case, are expected to give constructive inputs to the regulators, and so that those encouraging results can try to bring in the regulations. If there are regulations will unlock different business cases, and as a result, industry will be drawn towards those business cases and get into this field of V2X adoption. So with this, I would like to request Mr. Bjoern to give his comments around this particular aspect.
Thank you. I don't know so much about India, but I can maybe give you an idea about what's happening in California and in Europe. And we can learn from that. And I think that was part of the study, that we didn't want to reinvent the wheel. We really want to get this on the shoulder of what has already been done. Also, we may want to look at the bigger picture. And for example, China in December last year, in the Planning Commission, basically are going full-blown V2X in China now, with demonstration, very large demonstrations starting in 2025. So that being said, in California, and I'm taking maybe a little bit positive, I know that there's a lot of challenges, but first of all, V2X or V2G is allowed in California if you have a DC charger. So if the communication between EVSE charging station and the car is based on DC, then it's allowed. So the regulatory regime is in place. What's missing is the tariffs. Tariffs are still not there to really to award vehicle to grid, but it's being worked on. That's point one. Standards are already there. 15118 ISO 15118-20 or 2, but it's there. That is communication between the EV and the EVSE. We have now managed, after 10 years after Chatham did it in 2014, we have now managed in Europe and with trials, but also with the real implementation from the car manufacturers and charging station manufacturers to implement CCS2 with 15118-20. That's a very big step forward. Also, the communication between the charging stations and the back end with OCPP, different versions. It's de facto standard, but so I think we're very good on the standard side. What's really missing is the interoperability. Just like in the in the cell phone industry, we need to make sure that the interoperability is there so that any car can work with any charging station. And we're still some way away from that. There are some very interesting things going on in Europe that I can't really relay here, but it's being tackled. Now, we talked about the technology and the supply chain is happening very, very fast now, especially in Europe. The Volkswagen MEB platform that is being used for all the ID models, ID3, ID4, ID5, ID7, and the bus model, they are all bidirectional since last year. There are, for example, in Sweden, there are 20,000 cars on the road that are bidirectional. Now, they have not been released, their software, but they are there. The first charging stations are now also available in Europe with CCS2, and so we will see very soon. We will see from the supply side. We will see the application, the V2X application coming out. Now, the cost is an issue, and that's being tackled as well. California has now determined that we will introduce a new UL standard. It's called a UL 1741SC, which will allow us to do AC V2G, which would lower the cost substantially. So that's a cost issue. The grid codes will also be covered by that. So it's based on international standards. So we are addressing the issue of different grid codes. The last thing I want to mention is the business plans. There are business plans now, and many of them are tackling not the consumer, but are tackling the fleet owners. Because the fleet owners, they need some education, but the education is more on the economic level. What's in it for me? How can I save money? How can I increase my competitive situation? How can I electrify my fleet? So I think that that is also being tackled. The biggest issue that I see is really in concurrence with the previous speaker is education. People do not know about, they don't even know about electrical vehicles, and we should be very careful with the proper education to make it extremely simple, because people are very confused. Don't even talk about V2X, just to start with, having electrical vehicles. So over to you, Mr. Zakir.
Thanks, Bjoern, for your inputs on what is happening in California and Europe. What I meant by regulation requirements was both technical regulations, that is grid code technical, connectivity regulations, as well as the commercial regulations, that is around the tariff. So when I say regulations, it included both technical and commercial side of it. Now, awareness, as Dr. Sandeep mentioned, it is one of the important interventions that plays a role not only in vehicle adoption, but also this V2G and V2X adoption. Even in this study that we have done and some of the previous studies that have been carried out, awareness is being shown as one of the key countermeasures or interventions that plays a significant role than what is generally thought of from the awareness side. So I would follow up on the same question, awareness side. You mentioned, Dr. Sandeep, discoms and other players or stakeholders can play a role. But in Indian context, what in your opinion would be the effective way of, having this effective awareness to bust those misconceptions around various aspects of electric vehicles and V2G and related aspects in general.
So let me put this question in a slightly different. Let me answer in a slightly different fashion. The consumer, in India is mostly not reading the things. He's going, trying to understand the implications of everything by hearing what he hears from the market. And I give you this example because, we did a lot of market survey when I was trying to do the star label and the B. And I found that the people would not read anything between the labels. They will only see it's a 1, 2, 3, 4, 5 star. And depending upon his perception of the actual energy consumption, will buy the product. And we had the focus group discussion. We had this, pictorial description. But we found that the people had this buzzword of 5-star in the hotel industry, and therefore they thought that it's very important to buy a 5-star product. From that energy perspective. And you have seen the result today. People are definitely buying the product based on the star rating of the appliances, which has happened. So I have understood one thing, that the consumer perception of the events is not what the discoms, what the regulators, and what they perceive. They are completely different and alienated from the regulatory process. What I make behind the regulation is none of their concern. Consumers do not want to understand the implications and the eccentricity of the process by which the discom has to provide. They simply want to have a plug and play device. Even in this particular case, if there is a product which comes, okay, if I plug this into this socket, my device would work. And I can give you n number of examples around the product and appliances which I have done through the labeling process. Anytime you buy a new product, Indians never read the leaflet which comes with the product as a safety product. We open the product and start plugging it into the device, and device should switch on. Same is the case of vehicle. Whether we know the regulation where the gear oil is, where the gearbox is, but what we do is we simply put the ignition key and start driving the vehicle because we know how to drive. So in my personal perception, the regulation and the intrication should be left to the regulators and to the people who are making it, for which you, me, and possibly Dr. Bjoern and Mr. Singh is required. But other than the consumer simply wants that if I plug the socket into this, the grid will go in. If I plug into this socket, my vehicle would charge. If that is the answer, beyond 2x2 matrix, you put up a third matrix, it becomes a simple, complicated matrix for him. And therefore, simplification is the key if you want people to really understand the value proposition of V2X. I think that's my learning over the last 15 years of making regulations on every aspect, be it appliance regulation, vehicle duty, heavy duty vehicles, even electricity. So my take is very simple. Keep it simple for the people to understand it, and let the complication be done by all the people around that whole things to be done by the other people. So consumers should be kept intact. The last thing which you just mentioned, I wanted to add to that. It's not only the technical regulation of the electricity. It is also the regulation of the vehicle which is required to be addressed. I think we should not forget this point, that if you're talking of V2X, the most important component is V. And if V is left out, nothing will move. So please, I think in this entire effort, let me also give you, I was in the TD committee 10 minutes, half an hour, I get 2:45. The people are making hydrogen regulation of heavy duty vehicle, which we'll see after some years. But the regulation on vehicle is already out. They are making it regulatory process now. It will take 4 or 5 years to have it happen. So please start doing that activity right now. And it is important for you to take this message to both ARI, ITET, and other issues, to them so that they start making the regulation under BIS. That's all. Thank you.
Thanks, Dr. Sandeep. Two important points that I could make quickly from your this remark. One is this awareness, making it easy and simple for the customer, which is very important, where also this along with this modularity and simplicity of the device comes also comes this interoperability, which will actually enable that to a reasonable extent, in my opinion. And awareness initiatives, efforts by different stakeholders need to be done. I think that is very well taken. And the second point is around the vehicle side, which is very important. Vehicle, we are talking of the regulations from the grid side, but vehicle is also important. So therefore, that's what had happened in the Shadow protocol, where, because it was designed by the grid operators in consultation with the vehicle OEMs. So OEM understood what is required by the grid if I connect my vehicle to the grid. So that sync between the vehicle side and the grid is very much required, even in V2G and other aspects. And that was largely seen missing based on what I have understood in CCS 2+, where not much focus was given on the grid side, more focus was given on the vehicle side. So therefore, that's very important point. There has to be a balanced consideration of both the vehicle side and the grid side, and the two need to be actually in sync while developing these regulations, so that the vehicle is compatible with the regulations of the grid side, and the grid side has an understanding of the limitations and the capabilities of the vehicle when it comes to V2G side. Any related thought, Mr. Ramkrishna, from your side on this aspect? Regulation from the vehicle side as well as the grid side, and maybe something around awareness, if you would like to add upon.
Yeah, I think very valid point taken up by Bjoern, and also that other important is a simplicity by Dr. Sandeep. So what I understand, for any successful implementation or rollout at the all India level or globally, it is very, very important that we take all the stakeholders on the same platform. And the end user or the customer is a very, very important. Ultimately, he is the purpose for this entire ecosystem. And unless he understands the product, its benefit, so what is in it for me, that has to come out very simple, very, very simple, for this entire ecosystem, so that customer can get attracted on its own, rather than somebody goes and explains him that what is all in it for you. He should come and ask to the OEMs or to the concerned stakeholders that what is in it for me. So I think and this can be implemented by central agencies. I'm sure the kind of, maybe Dr. Garg could be one of the platform for taking up this kind of initiative, through which we can make it a very simple statement that what all can be for individuals, for the families, for the future. So not only the monetary term, but also the overall life, better life is being made by adoption or by implementing this entire ecosystem. So I think we should not be only taking in the monetary term, but also the quality of life which gets enhanced because of the pollution, whether it's a noise pollution or the air pollution, and also the directly the tailpipe emission for the cities like Delhi, Mumbai, Hyderabad, Bangalore, Chennai for that purpose. So which are badly affected because of large number of vehicle penetration in these major metros.
Thanks, Mr. Ramkrishna, for the constructive inputs. Let us move to the another related aspect that has been mentioned from the beginning. The director of IIT Bombay initially highlighted that if we charge vehicles in the night, it is likely that the power drawn for charging vehicles will come from the conventional power plants, and again, hence the basic purpose of moving transportation to the electrifying the transportation is getting defeated. So therefore, looking at how much carbon emission is there because of electric vehicle charging load that is getting added to the grid, brings us to the question of how we can achieve RE integration or renewable energy based EV charging in India. We already have, to a reasonable extent, some of the aspects that are there. Of course, there are multiple constraints, particularly in Indian context, but with all those constraints we have, let us try to see how best we can actually, while doing this electrification of transportation, also keep in mind that we are, trying to have increased uptake of the renewables through this electrification of the vehicles. We already have this green open access and other possibilities through which we can have our co-located renewable energy plants for RE-based EV charging in the country. So I would maybe request Bjoern, from the global perspective, what is your opinion? How we can have 2 points: RE-based EV charging, maximize the EV charging load is fed or supplied from the REs, and also how our EVs can be better utilized to increase the RE penetration in the grid.
Well, one thing that is certain is that we need more energy because we want to electrify everything, and we want to cut down on the carbon emission, and transportation is a very important part, as you mentioned before. So those are given facts. We also want to introduce more renewable energy into our grid. Wind costs are coming down. We're moving to offshore wind, and solar, of course, is a non-issue. There's so much of it, and it's very low in price. So with all that renewable, we're going to get more volatility and into the grid. And that means we need much more flexibility. And one key flexibility is batteries, it's storage. So we need storage. And we need to keep in mind that when we have millions of electrical vehicles, whether there's 1, 2, 3, 4 wheelers or 18-wheelers, they will be the biggest energy storage resource in the grid. And whether we like it or not, those electrical vehicles will come. So we better get prepared. And I think that having these two very giant industries meeting, the transportation and the automobile sector, they need to cooperate. And I just want to address the previous question maybe a little bit. For the 1511-8-20, there's been running a 2-year trial funded by the California Energy Commission in Southern California, Edison, which is a grid operator down in Los Angeles area. And the result has been published about 14 days ago. And the result is that there's been a gap analysis on the 1511-8-20 protocol. It was correctly, as you said, Professor Zakir, done mostly by car manufacturers in Germany to counter the Challenger protocol. And 10 years after that, they managed to come out with the 1511-8-20, but it does not address the grid adequately, the grid code issues, and it does not address adequately all the safety issues. And that has now been hashed out. And as I mentioned in the beginning, we will have in Rule 21 in California, which governs all distributed energy resources. It will be, the new specification will be out for public comments in July this year. And I expect it to be implemented next year in the Rule 21. So we need the electrical vehicles into the grid, and there's no doubt about it. And if we don't get on in front of that curve, we're going to head for a very, very big problem. So I think, maybe it's not addressing exactly your questions, but I think right now, India has an enormous opportunity based on your research, and hopefully it's going to be followed up with regulatory issues and all the administrative issues that needs to be done. There's an enormous opportunity for India to really get in front of this game. because we are only in the beginning of we're just scratching the surface, just like the internet. So there's so much more to be done. And energy, India being one of the biggest polluter in the world, and one of the biggest, having one of the biggest electric grid, and having enormous cost advantage. I think that, from my perspective, I hope that this webinar and others will lead really to the ball really start getting rolling in India, because I see enormous opportunities.
Yeah. Thanks, Bjoern, for your inputs on both the points that were being discussed right now. I would request Ramkrishna Singh, Mr. Ramkrishna, if based on your field experience that you have around electric vehicle charging infrastructure deployment in India, what is, in your opinion, what could be the measures taken to achieve this renewable energy based EV charging in India?
Hello. So Dr. Zakir is, I think, very valid point, and very important, that how this vehicle charging along with the rooftop solar, taken up, so that the real benefit. So so it is on today, it's a brown power electric vehicle is consuming. Most of the electric vehicle are using brown power. Okay. So brown power means is on date around say 25% renewable is getting generated. So 75-25 mix is there. Apart from that, even if it is the thermal power, it is a more efficient power compared to the diesel or petrol directly getting burned to the vehicle. So in case like you are also showing in your study that how they integrated, and if we can coordinate or collaborate with the discoms, because discom is having the entire integration with the rooftop or the renewable generation happening at particular point of time. And if we can come out with some kind of policies for the kind of the Prime Minister rooftop solar scheme has come up for the individual household. Similarly, if that can be extended to the specific to EV owners, like the EV tariff has been specifically encouraged a lower tariff compared to even household tariff that EV tariff is. So if similar schemes can come up with the this EV car owners, although there would be challenge in some of the some of the cities primarily because they don't have access to the roof, but the B and C class cities directly get benefited. And also is on today I am having many of customers which have got the rooftop solar installed at along with their home charging solution, and they try to ensure that they run their vehicle totally on the green power. For that purpose, like I would like to share with all of you that in Mumbai, all our chargers are feeding only green power, 100% renewable power, which we are sourcing from the either renewable solar generation or hydro generation, and we are charging slightly higher. Although public chargers we are keeping the same tariff, although it is 0.5 0.50 paisa, 57 paisa is higher for the domestic customers, but we have kept it. We are not charge anything on this, and we are more than 1,000 plus charge points in Mumbai city. They are feeding 100% green and renewable power. Similarly, many of the states have come up for the tariff with the green power, wherein the discom will procure the green power and provide to the customers. But if customers can directly own the rooftop solar, it gives the different sense of pride, and also some kind of like a proud income tax filer. Okay, so can we bring some kind of awareness that proud rooftop solar or green hero or the green energy consumer kind of concept? I'm sure it is an excellent idea and it's a very implementable.
Thanks. It is interesting to know that your all chargers are being fed from the renewables in Mumbai. And as we also have seen in this field demonstration with this rooftop PV, along with V2H, is becoming more economical and helping in saving more electricity prices on annual basis that we did from the measurements. So that is even evident from that analysis as well, those measurement analysis. So I think we are running a little bit late. So I would like to have the final, maybe one statement remark from all the panelists. In your opinion, what you think, should be, let us say, a key countermeasure or key intervention that we should adopt, or in your opinion, what could be actually a major enabler for this V2X adoption in India? Dr. Sandeep.
Yeah, okay. Fine, I go first. I think for adoption of any regulation in India, the matrix of the understanding should be made as simple as possible. If you make it simple, the adoption will be faster. Unlike that, you have to undergo many of the regulatory process of taking approvals either from the government or from this, and that it becomes a complicated process. Half of the people lose their steam, before they actually get into the process of doing so. And that major example is renewable is one of the good case to understand that. So I think my message is very loud, clear. Please make it simple so that consumer can adopt it, because he is at the center focus of everything.
Thank you, Dr. Sandeep. Mr. Ramkrishna.
Yeah, so first thing is a simple, like let's make it simple, and another important point is affordable. So the entire solution has to be affordable so that customer can opt it. And then the suitable regulation, which I am sure are in a way. Technology already in a way. So that affordability is as of now is a key for existing technology or evolving technology and upcoming regulations.
Right. Sure, thanks. I mean, that's true that affordability is the key in adoption of the new technology, and as we talked about, regulations are going to play a key role in that. So thanks, Mr. Ramakrishna. Bjoern, your final thoughts.
Oh, it's difficult to add to what has already been said, but I think it has to be efficient, it has to be affordable, and it has to be simple. And then the heavy lifting has already been done, for example, in California, where I reside. So there's been enormous amount of right people that has been, get going at this problem. Let's learn from them. Let's, let's establish better connections between the two regions, and not to forget Europe. And I think let's learn from what other people have done so that we can collectively move forward. So that's my main message.
Thanks, Bjoern, for your final comment. I think we already overshoot. I would like to thank all the panelists for your participation in the panel discussion and enlightening the audience around important aspects around about this V2X adoption, and some of the aspects that we had not planned, but in the discussion they came up very, very relevant points around this V2G and V2X adoption during this panel discussion. So I would like to thank all of you for the time that you took from your busy schedule and joined us in this panel discussion and enlightened our participants of this workshop, this webinar, with your constructive and thoughtful input. So thank you so much for your participation in the panel discussion. And I also would like to thank Mr. A.K. Rajput for his valuable inputs in the beginning that he gave around these electric vehicle and vehicle to grid adoption in Indian context. So thank you so much. So with this, I am concluding this session and handing it over to Ruchi. Thank you.
Thank you, Dr.
Thank
Zakir.
Thank you.
Thank you so much.
Thank you, Bjoern. Thank you, Singh. Thank you, Mr. Singh. So kind, sir.
Thank you.
Thank you.
Thank you, everyone. This panel discussion effectively presented like emerging challenges and highlighted the interconnection between various sectors in adoption of V2G technology. I extend serious thanks to all the panelists for their valuable contribution to this engaging conversation. Since we have like a inadequacy of the time, we would be putting up the Q&A, answer to all of queries on our GIL page and LinkedIn page as well. So with this, we have come to end of the event. Therefore, I would like to go ahead with the vote of thanks. First and foremost, I would like to thank all our esteemed guests, Shri Ashok Kumar Rajput, Mr. Ramkrishna Singh, Mr. Bjoern Christensen, Dr. Sandeep Garg, Professor Shireesh Kedare, and Professor Zakir for taking out time from their busy schedule for this event. Also, CEA and the GIL team for engagement during the field trials and this event organization. Lastly, I would like to thank all the participants for joining us in this webinar and making this event remarkable. Thank you all and have a great evening.
Thank you.
Welcome. Thank you.
Thanks.
Thank you.
Thank you.